Now in this lecture, we are going to compare array implementation with linked list implementation in case of binary tree. Now here, the first operation is creating of binary tree. Now when we are creating a binary tree using array, in this case, time complexity is O1, because here we are just declaring fixed size of array. Now in this case, the space complexity is On, because when we are declaring a fixed size of array, we have to allocate n number of contiguous cells in the memory. So that's why space complexity is On. Now in case of linked list, the time complexity will be O1 because here we are just creating the head references in linked list. Now the space complexity is also O1 because in this case we are not allocating any cells in the memory. So that's why creation of binary tree in case of linked list will take O1 time complexity and space complexity. Now when it comes to inserting a new node to the binary tree, in case of array it takes O1 time complexity and space complexity is also O1. But in case of linked list, it takes On time complexity and On space complexity. So it takes On time complexity because here we are using level order traversal to find the deepest node, so that's why it will take On time complexity. Now the space complexity is also On because in this case when we are using level order traversal, we have to create a queue. So here we are enqueuing the all elements to this queue and we are dequeuing the all elements from this queue. So this means that it will take On space complexity when using level order traversal. Now when it comes to the deleting a node from binary tree, in this case, the time complexity in case of array implementation is On because here we need to find a node in the array. So here to find a node, we are using level order traversal. So we know that level order traversal takes On time complexity. So the time complexity for deleting a node from binary tree in case of array takes On time complexity. Now the space complexity is O1 because in this case we are just updating the value of cells. So an extra space is not required to perform this operation. Now in case of linked list, the time complexity for deleting a node from binary tree is On because here again we are using level order traversal to find a node and replace it with the deepest node, so that's why it will take On time complexity. And the space complexity is also On because in this case we are using level order traversal to find a node that we are going to delete. So we know that in case of level order traversal, the space complexity is On. Now when it comes to the searching for a node in a binary tree, in case of array it takes On time complexity because in this case we are using level order traversal to find a node. So we are visiting all nodes of the binary tree and checking that if this is the node that we are looking for or not. So in this case, in the worst case, if we cannot find the node in the binary tree, it will take On time complexity. Now the space complexity is O1 because in this case, an extra space is not required to perform this operation. We are just looping through the arrays. So that's why it will take O1 time complexity. Now in case of linked list, the time and space complexity is On because here again we are using level order traversal. So in case of level order traversal, we know that the time and space complexity is On. Now when it comes to the traversal of binary tree, we know that in both cases we have 4 traversals. So the first one is pre-order traversal, then the second one is post-order traversal, then the third one is in-order traversal, and the fourth one is level order traversal. In all cases, we have to visit all nodes of the binary tree. So that's why if the number of nodes in the binary tree is On, so it will take On time complexity. Now the space complexity for traversing a binary tree in case of array can be O1 or On. Now in case of in-order traversal, pre-order traversal, and post-order traversal, the space complexity is On because in this case we are calling these methods recursively, so we have to insert elements in the stack, so that's why it takes On time complexity. But in case of level order traversal, we don't have to use the methods recursively, so that's why it will take O1 time complexity. Now when it comes to the linked list, in linked list, all 4 types of traversals will take On time complexity and On space complexity because in this case, as I mentioned, for the time complexity, we have to visit all nodes of the binary tree, so that's why it takes On time complexity. But for the space complexity, for pre-order, in-order, and post-order traversal, we are calling this method recursively, that's why it takes On space complexity. But for level order, we are creating a queue and enqueuing the all elements of the binary tree to this queue, so that's why it takes On space complexity. Now when it comes to deleting a binary tree from the memory, in both cases, it takes O1 time complexity because in case of array, we are just setting the array to null. So in this case, an extra space is not required, so it's not time-consuming operation. So that's why space and time complexity is O1. In case of linked list, we are just setting root to null. So this means that we are deleting the links of children. So that's why in this case also an extra space or an extra time is not required to perform this operation. So that's why the time and space complexity is O1. Now if you compare these two cases over here, we can easily see that in case of array, it's not space efficient because whenever we are creating a binary tree, it's allocating n number of cells in the memory. So this means that even if we have not used these cells, it will be located in the memory. So this is not space efficient. But in case of linked list, this is space efficient because when we are creating a binary tree using linked list, in this case, it takes O1 space complexity. Now, in terms of time complexity, both cases are similar. We have only differences in insertion of a node to the binary tree. In case of array, it takes O1 time complexity. In case of linked list, it takes On time complexity. So with this, we have come to the end of this lecture. So in this lecture, we have compared array implementation with the linked list implementation. So it depends on the situation which one you are going to choose. So if you want space efficient implementation, in this case, you should use a linked list implementation. Otherwise, you can use array implementation. Now with this lecture, we have come to the end of this section, which is binary tree. So see you in the next section.